Welcome back to another video. In this video we are going to study grid in SwiftUI. So let's start by creating a new file and name it as grid playground. So grid view arranges child views in rows and columns, and it further has two components, LazyVGrid and LazyHgrid. LazyVGrid is a container view that arranges its child views in a grid that grows vertically, and it only creates item when it needed. So because it's a lazy, so if it only creates the item when they are actually required on the screen. So let's start with an example. We are going to wrap our grid inside a scroll view because we know since it's a grid, so it can go beyond the screen. And inside the scroll view, let's just first look at LazyVGrid. And you can see in the initializer, we have to provide the list of grid items for the columns. So we have to, this VGrid, it needs column to work with. So let's just first specify columns. And each column actually is a grid item. So grid item it allows us to specify size, alignment and spacing for every column, and it further has three sizes: fixed, flexible and adaptive. Fixed is a single item with fixed size, so if you specify 50 points, it's going to be 50 points. Flexible is the item, its size can be adjusted depending on the available space, and adaptive is a multiple items in a available space. So we will understand them more clearly with the example. So let's start with the fixed size grid item. We have this array of columns, so let's just define our first column and use a fixed size of maybe 60, and then we can use these columns with our grid. And for the content, let's just have, for each we can actually use static content as well, like maybe this element 1, element 2, element 3. So it works with both dynamic and static elements, right? So but let's just have for each in here, and maybe we want to display 20 elements on screen. Let's just have text that says maybe element, and we want to have padding and then just some background with opacity of maybe 0.3 so that we can see it's the background. So now we have our grid on the screen, and we can see that with this fixed size of 60, it's not like much for this whole cell. So let's just maybe increase it to 100 and see if this fits. Yeah, I guess 100 is better. We can increase it to or maybe 120 so that we have both element and a number on a same line. And this is one column grid. So let's just create another column, and we can do this by adding another grid item, and let's just use fixed size 120 points. Now we will have two columns inside our grid. So yeah, so this is how this fixed size columns looks like. And yeah, we can actually do one more thing. Instead of since these are the same columns, so instead of repeating them, we can use a repeating array in here, and for the element we can specify our grid item, and for the count let's just maybe use 4, so that we want 4 columns for this fixed size grid item. Yeah, so this is what we expect with the fixed size. If the because since the size is fixed, so it's not going to adjust itself. And if there is no the available space is not much, or for all the item, then it just goes beyond the screen. So this is how this fixed size grid item works. Next, we are going to study flexible grid items. So I will just comment out this code in here. Let's write another scroll view, and this time we actually need columns. So let's just have another column array, and this time we need it for the flexible. So let's just have flexible in here. So we first have to use the grid item, and then we can, in the size, we can specify the flexible, and with the flexible we can specify a minimum and a maximum values. Since it's flexible, so it will try to adjust the columns within the range of minimum and maximum value, but it works without it, it also works good. So let's just have a lazy v stack, sorry, not the stack, a grid, my mistake. And for the columns, we are going to use the column that we just created, and then we just need for each, and yeah, we just need to go till 20, and it's the same thing. We just want element and then the number of element, and for the padding, we want a padding and then a background, this time maybe up to background with opacity of 0.3. So now we have our grid with a single column, and you can actually notice this thing here. The width in here is, this element 10 has a greater width than the element 9, and this is because the list or this grid is actually flexible. So what we can do is we can again use the same array for the repeating elements. So let's just have array, and this time we want maybe two columns within our grid. And you can see that we haven't specified the width or we haven't specified any value, minimum or maximum, for our grid items, but it's automatically adjusting it. Let's just use maybe 4 columns, and it will try to adjust these 4 columns within the available space. So that's what the definition is for this flexible. It adjusts, it's a single flexible item in the available space. And if we actually increase further these columns, and it is still going to adjust it within the available space. See, so although the width of the items is not very much what we want, because we want to see a complete item on screen, but still it's trying its best to fit with what data we have provided. So this is how we can work with the flexible grid, and the last grid item is adaptive. So let's see. We are going to comment out this scroll view. Let's just have another scroll view, LazyVGrid, and this time we will already have a column at the top. So just comment out this one, and let's just have a grid item, and for the size we want adaptive. In adaptive actually comes with a minimum space, so let's just say we want a minimum space of maybe 60, and yeah, now let's just have this for each in here. We want 20 elements on screen, and sorry, it's two dots, not three. And then we can have our text in here that says maybe element number, and yeah, sorry, we need padding, sorry, and then we need a background. Let's have maybe yellow background this time with opacity of 0.2. So now you can see we only have a single column in here, but since the definition says that what adaptive does, it tries to fit multiple items in available space. So even though we have a single column, but it still is trying to fit all the other fit the other elements or the other items inside this row, in the first row. So this is what it does. It doesn't care how many columns you have specified. It always tries to fill the available space. So let's just have 120 as minimum space. And now we have three um, elements or three items, but since it's but even though it's a single column grid, but we still have three columns in here. And this is because this grid is this adaptive column is trying to fill multiple items in available space. So this is all about the grid. I hope it was easy to understand. If you have anything, you can leave a comment. See you in the next video.